interaction. The easiest one is the key object, which basically just whatever key is pressed, it gives you, and if I lock my patcher so I'm not using shortcuts, it gives me an ASCII table value for the key that's pressed, right? So if you want to trigger something on a space bar, I can hook up the key to a message so that I can see, or an integer, and I hit the space bar and I see that that's 32. I hit the enter and I see that that's 13, right? So say I want to trigger something on enter and I want to trigger something else on space bar. That's simply saying select 32, select 13. You can have different select objects, or you can put all the different things you're selecting in the same object and it has one output per selection, right? So this is if it bangs, if it matches 13. That's the return key. And this is it bangs if it is the space bar. Space bar, one word or two words? Space bar, one word. All right, so now space bar, return, right? So I could do whatever I wanted with that. Here, let's do an audio thing real quick. Grab any sound, grab a sound, two sounds, any two sounds. One sound. The two sounds, and then we need an easy DAC to be able to hear any of the sounds. Patch these in here. And then you trigger a 1, I believe, to make it play. Somebody figured it out already. And a 1 over here to make it play. So, right? So that's easy. It's really simple. What if you wanted to take text input from something? There's a text edit object, text edit, and when that outputs, it sends the word text followed by whatever you sent. Test, so it says text test, right? So what we can do here, I'm gonna disconnect this so it's not driving us crazy. All right, so what we can do is route for the word text. So then whatever you typed in should come in over here without the word text. Right? Hello world. So say you want to, first of all, you want to have the text enter when they hit the return key instead of putting a new line. There's a inspector feature for that called return enters text, key mode 1 basically. So under the inspector for this text edit object, this is a text edit object. Over here, return enters text. Why can't I zoom in? Oh well. Return enters text. Not tab enters text, sorry. Return enters text. Right, so now whenever I hit enter, it'll put out what I put in. So, you who. It didn't work. Yeah, it did. There we go. Okay, so, yeah, question.
Where was the return enter text?
Under inspector for the text edit. Yeah. So now, say you wanted to trigger something when they said a particular word. That's easy enough. You can just use a select like you did with the numbers here. I could say, whoops, new object, select hello, And then if they just put hello in this, you get it. If they put hello space something else, you still get it. But if they put something else and then hello, do you get it? I don't know. You don't, right? Because it sends this out as a list. And the select will only ever look at the first value of a list. It won't go through the items of a list. So what you could do is you could say iter, which will iterate through the list one thing at a time, and then put that into the select. And so now if it says blah 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 hello, I still get that select banging. Okay? Oh, sorry, yes, cell and select are the same. Select is the old way of typing it. Yeah. Okay, so there's another way. Here's another way for text. If you have like text coming in a data stream and you want to trigger when it has a particular word, but you don't know how that word might come, you could probably do something with regexp. Regexp, and then the thing that you're looking for. Let's see, test. And then I believe it will output on substrings if it matches. So let's see. Hi tests by, yeah, and then it'll output the word test anywhere in what it receives. So that's you could then trigger an event based on a word coming in. Say you wanted to, if somebody wrote Trump with a capital T, you could trigger a fart noise or something. Right? Okay. Let me show you one other thing with regexp, and that's you can use regexp to substitute something. So I could say regexp trump at substitute jerk. And if I send this into here, now coming out of the substitutions should be the new sentence with the substitution. And so now I can change hi Trump by into hi jerk by, right? So that's another way of dealing with text and doing a search and replace, basically. Regular expressions, they're very powerful. There are some really powerful formulas that you can do. They're really hard to work with, but if you're just searching for single words, they're pretty easy to work with. But if you want really powerful search strings, there are forums on the internet that explain how regular expressions work. The regular expressions are used in multiple programs outside of Macs, so any of those examples that you see on the internet will work on this as well, with some minor idiosyncrasies, but mostly it works the same. Okay, cool. So let's see, 27. All right. Oh, wow. Yeah, so now mouse, right? Okay. So let's see. What do we want to do? Let's make a JIT world and a toggle to turn it on. So the easiest way to get mouse info for your window is either to use the mouse info that comes out of JIT world, but it only gives you the mouse info when you're clicking. That will give you the position in the window. So if I put a message down here and I go from the dump outlet to the right inlet of this message, and I click, it'll say mouse and then the value. But as soon as it only gives me the value when I am clicking. It'll tell you when you let up from clicking, but it won't tell you the coordinates when you're not clicking, when you're just rolling over things, which I wish it did. And I feel like there's a way to do that, but I can't find it in the reference, and I can't figure out how to do it. Yeah, you can use mouse state, which we'll look at in a minute. So this thing gives you a coordinate from and is it dependent on where your window is? No. It gives you a coordinate from the edge of the window in pixels based on the size of the window to the other edge of the window. And then it will give you pixels beyond that as well, but what you can do is you can basically you can unpack this value to get these numbers. So I can first route for mouse. And then all these numbers here, this is the X coordinate, this is the Y coordinate, this is whether you're clicking. This is whether you're, I believe, whether you're holding down Shift, Command, Control, Alt, or I don't know, function? Option? I don't know. Modifier keys. Not likely to need many of those, but you can get them if you need them. Route mouse. So then we can now unpack, and we really only need the first two values, I, integer, integer. And so now, or maybe we want the third one, whether you're clicking or not. So you can get these numbers here and toggle for whether you're clicking or not. So here, let's make this floating so that we don't have to keep tracking it down. At floating 1. There we go. I'll have to turn it back on again, off and on. All right. So if I'm clicking now, I get these numbers, right? And I can use these numbers to numerically trigger things. So if I just put something on the screen, let's just do that. Let's do a GL video plane at scale 0.25, 0.25. And then let's grab a picture, any picture, and drag it onto your desktop. I mean, not on your desktop, onto your patcher, and then put it into the video plane. And then you're going to need a button above that to actually put it into the video plane. Questions? Charlotte, are you okay?
Yeah, I'm fine.
Oh. Okay. So now we have this, right? So say we want to do something. I have this Boo Ghost. You don't have the Boo Ghost, but whatever. It doesn't matter. Just get a picture on there. So what you could do, you could just manually figure out what the pixels that line up with this and kind of manually figure out a box. So that I know works, right? So I see these numbers and I'm clicking, and as soon as it hits the ghost, I see that that's at about, let's see, the furthest left of the ghost is about 261 to about the furthest right is about 386. So I could say is greater than 261 is less than, what was it? And just figure out values for whatever you put on the screen. In my case, is less than 385. 385. So, and attach the output of the X coordinate to both of these. Not the X and the Y, just the X to both of them. Then we need to also now have is greater than and is less than for the Y coordinates, and let's figure out what those values are. So it's going to be great. This one is 300. Over here is 170. 170. So I'm going to say greater than 170, less than 312. So greater than 170, less than 312. And patch these in here. And now these are all going to give a 1 or a 0. And if they're all 1, then it's inside the box. So all we need to do is add them all together and then select for a value of 4. So plus, you can either use a couple plus objects, 3 plus objects. Just remember that it's going to, unless you specify otherwise, it's going to do these from right to left and then from bottom to top. So from right to left, I'm going to first put in this value, then I'm going to trigger this calculation, then I'm going to put in this value, then I'm going to trigger this calculation. Right. I didn't need 4. I only needed 3, like I said. Sorry, I got confused about what I was doing there. And then put in this value and then finally trigger this calculation. Okay, so this should give us a value of 4 if we're inside the box. See, I have 4, 3, 3, 2, right? I'm only get a 4 when I'm inside the box. So now I can say select 4. And actually what I should do before I do that is do a change object, because otherwise it's going to be sending 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, you know, every time. So this will only send the value if the value changes. And now I can say either equals equals 4, or I could do a select 4 if I just want to bang. Toggle, or I could do a select 4. So this, like I said, this only works when I'm holding down the mouse. Okay, so let's look at how we might be able to use mouse state. And I'll show you also the problem, some problems with mouse state. Mouse state. So mouse state will, this is like 1 if the button's down, 0 if it's up. So that's, we can have a toggle attached to that. This is the horizontal location. This is the vertical location. And then this is delta. Delta is a change. So you can actually use these values to detect if somebody is really hard moving their mouse in large things. So you could possibly use the delta outputs from a mouse state object to do like impulses in your physics, so that if someone moves the mouse really hard, it's like they're punching the bag harder, right? Let's just look at that real quick, how that works. So this is a delta value. Oh, and you need to get this to work, you either have to send a bang every time you want a value, or if you don't want to have like a metro running it, you can just say poll and it will do it automatically. But you have to, at least at the beginning of your patch, you have to send the word poll once. So now you see if I slowly move up, it'll give me a delta value of something small, either positive or negative. But if I move really hard, it'll give me large values, right? So you could possibly use those. But anyway, you also see this X and Y coordinate. And this is your X and Y coordinate across your entire screen. And this is determined by the resolution of your screen. So right now mine, because I'm connected to the projector, is 1080p, 1920 by 1080. But yours might be something different. Yes?
Sorry, what are you typing to get poll?
A message that says poll.
Oh, I'm sorry.
Poll means anytime you have something that is taking readings on an interval, that's called polling. So it means it's like voting. It's like the polls are open. We're reporting our results as they come in or whatever. Yeah.
And is that less processor heavy than another?
No, it's probably more processor heavy.
Okay.
So if you only need to check when somebody clicks, then maybe you don't use poll. You just, when they click, you send a bang to the mouse state to get their current location when they click. So that would use less intensive. Yeah.
One more question.
Yeah.
Oh, actually, I just figured that. Never mind.
Okay. Cool. So let me show you. There's a couple other things that might help you on this. So right now, this doesn't help us very much figure out these coordinates. I mean, they could, and I could do the same sort of thing with these coordinates here and say, okay, well, this is when it gets to 249 and when it gets to 392, which is similar to these values because I have it in the upper hand corner. But if I move this over here now, those are going to be completely different values because these are my values across the entire screen. So what you could do is you could change the mode. There's different modes. There's mode 0, mode 1, and mode 2. Mode 0 is the default, which gives you the let's see, we just need a mode 1 and mode 2. Mode 0 is the default. Okay, mode 1 gives you your coordinates relative to the upper hand corner of the max window, I believe. Something like that. I'm not even exactly sure. I know mode 2 is the one that I think you would probably use if you weren't using the regular one, which mode 2 gives you the coordinates based on whatever window you have activated and is highlighted. So that will give you a nice coordinate that goes from 0 to the resolution of the screen, of the window, right? So that's a little bit more useful for this because then I can always say, okay, this is the ghost is between 259 and 384. And it doesn't matter if the window is here or if the window is here, right? If you go full screen, these values are going to change because the size of the window changed. Does that make sense? So you would have to figure out what the pixels are for this size window, depending on the size of your window. The part that I was trying to do this morning, and I couldn't get to quite line up for some reason, was to normalize these values from a -1 to +1, depending on the size of your window. You can send to your jit.world the message get size. And then it should be coming from the dump outlet, the size of your window. And then I could say, okay, well, if it's a 640 by 480, the values here should be coming from the mouse. If it's in mode 2, the values should always be between 640 or 480, unless it's a negative, unless you're past the screen. Where did my mouse state? There it is. So 0 to 640, right. So what I was saying was, why don't we just take this get size and unpack, what happened? Oh, right, here it is. Unpack this, so I'd have to route size, right? Route size. And then unpack. We only need actually 2 integers. Unpack the size. So every time I hit this, get size, I get those 2 numbers. And now I could use those in a scale. I could say scale 0 to 640 for now, but this will change based on if the window size changes. Between -1 period and 1 period. And this would be the input high value. You'll never have something lower than 0 because well, you will, but you don't need to worry about that. You don't need to worry about changing that input number. Then you'll have the same thing here, 0 to 480 for your initial value, but it will be replaced by input high input value. So then this will give you a value between, this should give you a normalized value between -1 and 1. And make sure that you have float boxes here. So get size, right, and then we just need to actually attach these scale inputs to the value coming from the mouse state. So this is the x coordinate, this is the y coordinate, and now it gives me a number that goes from, it should be 0 in the middle, and it mostly is, to 1 on the side, and then from 0 here to 1. See, that is not working right. What did I do wrong here? No, that's right. 1 to -1. There we go. Yeah, it's working. Oh, it was because it'll only work right if I make sure that this window is highlighted. Remember, because we're in mode 2. Mode 2 only reports the mouse on the highlighted window. But if you're full screen, that's going to be the highlighted window, right? Also, if you're full screen, you'll always know what your resolution is if you know what monitor you're attached to, and then you can just specify everything with pixel values that are going to stay consistent. So this really isn't a problem once you go into full screen. It's only a real problem and pain in the butt to deal with when you're working with windowed values. All right? So what I was looking at today, when I tried to then use this normalized value to trigger something and I wanted to draw a square based on these values, and then if you're inside the square turns red. And it was working, except for everything was slightly pushed to the side. And I wasn't quite sure why that was. So as long as you don't use the same numbers to draw as to analyze, that wouldn't really matter. If you just figure out what number actually does line up with your picture and use that number, it'll work. Okay? We could look at more. This is only like one way of doing this. There's lots of different ways to work with these mouse numbers to do interaction. I just want to show you some of the base ways. I could go on for longer than this, but I want to show you the JIT multiple. So let's save this as mouse and keyboard interaction. All right, and now let's make a new patcher. And what we're going to do is I'm going to show you some of the basics of how this works, and then we'll download the patch from the website that I implemented a whole like installation, this cutesy thing with Cheerios, and we'll show you how you can utilize this in a full-scale thing. But I didn't want to take the whole class to build that together because it would have just been repetitive. All right, so jit.phys.multiple. Let's look at the help file for it. So if you open up the help file and you turn on where it says 1 here, you can see it's rendered all of these cubes. And then make sure you also click on the 2 here. This what is it? EasyDAC. And so it's rendered all these objects, and we don't have what, 64. We don't have 64 different fizz bodies, but we have we're seeing 64 fizz bodies. We don't have 64 fizz body objects. And so it's rendering these 64 fizz bodies, and it's applying different forces to each one. the forces are being calculated based on an audio analysis of a sine wave curve that it's doing, and then it's feeding that into a JIT expression to do a normalized values, which make all of these kind of uniformly have the same sort of forces, but the forces all kind of swap places over time, unlike a sine wave, right? So let's unpack what's going on here. So you have the jit.phys.multiple, and the thing to really look at here is the @phys params attribute. I used to be able to zoom in, and I can't anymore. Oh, it's control, I guess. Okay. @phys params, right? So this is what it will be looking at the matrix to fill in values for. So this case we are looking at we are sending it 3 different matrices. We're sending it a positional matrix here, we're sending it a scale matrix here, and we're sending it a force matrix, which is coming in from down here. Okay. Same thing with JIT GL multiple. It works in much the same way. Instead of phys params, it's GL params. And we're looking at position, rotation, and scale. Position comes in here, rotation comes in here, and the scale comes in here, and that's why it's fed by the same matrix that we're feeding this scale to. Right? Does this have a scale output? Dump out. No, it doesn't. Okay. Yeah. Great. So let's kind of copy what they're doing here, but we're not going to use their thing. We're going to make our own. So we're going to have a JIT phys multiple, and it's a 3-plane matrix because we need 3 coordinates for x, y, and z for position. At phys params, position, scale, and force. Position, scale, force. You can, if you put these wrong, if you put the wrong physical parameters, it won't tell you that it's wrong. It just will ignore it. I could put cheese here, and it wouldn't throw up an error. It just, if I sent it something to cheese, it wouldn't use it. All right. All right, so I'm going to take that out. All right, so then we need to feed it a matrix. Now, if we're going to feed it a matrix for positions in OpenGL are floats, right? They go from -1 to +1 in a float value. So this matrix has to be a 3-plane float 32 matrix. Float 32 means it's a 32-bit floating point number. So that 32 bits has to do with the maximum value that it can hold. Floating points have half of the range of like an integer because it takes the maximum number and shifts it into the middle so that you get a -half and a +half, basically. Plus floats use a lot, integers are a lot easier for the computer to deal with. But in this case, we need floats because we need the matrix. So we need, let's just copy this. Duplicate, copy from the help file this JIT matrix 3 float 32 4 4 4 4. This is a 3-dimensional matrix, 4 by 4 by 4. So that will give us 64 different cubes. You could do the exact same thing by saying float 32 64 by 1. The phys multiple doesn't care how you arrange the elements of your matrix. You just need to have 3 planes to represent the 3 values, and then depending on the size of your matrix is going to depend on how many objects it actually spawns. So let's go back to the default 4 by 4 by 4. And we're not going to use this expression. We're going to use noise. And actually, I believe we could, okay, yeah, let's just duplicate this JIT matrix and change the word JIT matrix to JIT noise. I believe this will work. If not, we don't really need this JIT matrix, I believe. I think we can just go straight from the noise right to the fizz multiple, because this really is just passing through whatever this is creating. We're going to need a JIT.world to be able to see anything. Okay. All right, so turn this on. We're going to need a gl.fizz draw so we can see what's going on here. And then we need a button, and we need to bang this noise to actually create the noise. And there we go. We see our objects are all created and they all spawn on top of each other. Let's close this help file now to give us some better performance. So every time I bang this, it'll respawn these objects in a random location, and then physics takes over. So let's get the camera controls. Go into world. Let's just grab the camera controls from world. So grab help file for JIT world. Copy the camera controls and paste them in. There we go. Now we can see better. Right? And then we should put a scale, a matrix for scale, which was a JIT dot, what was it? It was a JIT dot matrix 3 float 32 and only one value, because we're going to make them all the same thing. So actually you can just duplicate this matrix here and change from 444 to just 1. Okay, and then put a float coming into this. Oh wait, sorry, I put it into the wrong place. It needs to be into the scale array. Now all mine disappeared. Why? Did I mess something up? What did I do wrong? Did yours guys all disappear too?
Yep.
Well, crap. I think this is the same thing. Aren't those the same thing? Whatever. Does that bring it back? No, mine has gone away. Maybe my fizz draw is broken. Yes, my fizz draw is broken. All right, so as soon as I put my fizz draw back, I got everything back. So there we go. So now I can change the size of these by sending this value. Every time I change the size, it will respawn them all. Okay, so you could simply so say you wanted to all of a sudden spawn a whole bunch of things falling from the ceiling. You got that system here. All I have to do is send a bang to this thing. All I need to do is change either the scale value, resend the scale value, or resend the position matrix. Either one of those will respawn everything. Right? I can just bang this position matrix too anytime I want. Right? So we just created a noise. We could, and like I said, we don't really need this matrix anymore. We can just pass this straight in because that matrix is just passing along the same thing. We can now, if we wanted this position matrix to be amplified, because the noise can only make values between 0 and 1, so that those position will only go so far. We can amplify it with a JIT dot multiply and put a float value coming into the second inlet. And so now I can multiply this position, the amount of spread in the position by 2, or maybe I multiply it by 13, and now they're spread out a lot more. It looks like also, though, it's kind of a signed value. It's always positive again. See how that position is, it's never on the left-hand side of the screen. It's always on the right-hand side of the screen. And that's because your noise is not going to make negative values. So what you have to do in that case is just you do a jit dot minus, and you minus by half of this, of the what you're multiplying the range by. So I can say divided by 2 period. Make sure you put a period so it stays afloat. Put that in there. And that should offset the values back into the middle. So if I resend this number, that whatever I'm doing the spread, and now they're spread out all over this place. Right? Okay, so you can also now just attach this to a jit.gl.multiple. What do I have to do? Oh, and I have to put the same sort of things. I have to say at GL params position rotate and scale. This output is the rotate matrix coming out of the Phys multiple. It's already set up to work with this. Why do I only have 2 inputs? Oh, I have to say 3. That's the argument, is how many inputs there are. There we go. So now the rotate array goes in there. This is the dump out. We don't need that. This is the position matrix that gets passed along. The scale matrix can go straight in from this up here, straight into our GL multiple, because it'll be getting the same scale as the Phys multiple. And so now, oh, right, there's one more step. That creates the parameters, but we have to then attach it to a JIT GL grid shape. At lighting enable 1, at smooth shading 1. Boom. Look at that. Boom. Cool. So now you have 64 balls here. We can have a jit.phys.picker, and we can pick up the balls. One more mode of interaction that I discovered just this morning, I did not know this, is that you can get interaction from your Phys picker. I know, that sounds really dirty, but...
No, that's not what I was laughing at. I think I have a problem. Can you just,
What's your problem?
instead of circles, they're just, it's like a big, scale?
Let me take a look.
It's, my computer's been doing some weird stuff.
Oh,
I know.
you are crashing.
That's just, should I just save and we...
Well, is your... Yeah. Call this JIT Phys multiple, or just call it multiple.
Should I, I'll read.
Yeah, probably. That doesn't look too good. Okay. I believe this will tell you who you've grabbed onto. In the data here, you can see this is the physical universe name. This is the ID of the ball in 3 different dimensions because we did a 4x4x4. If we wanted to make this way easier for us to deal with as far as identifying which ball is which, instead of having this a 4x4x4, make it a 64x1. Same thing happens. You still get 64 balls. Now, if I grab a ball, it'll tell me this is ball 52. This is ball 10. And it says a 1 or a 0 whether I'm holding on to it or not. So how do I get those? It's a little difficult because, well, the mouse is easy to get rid of, right? Route mouse. So now that gets rid of that. Now I have the universe name and these 2 numbers that are separated by underscores. So what did we use today that I showed you? How you can separate out, you can search for particular things in text? The regular expression. So I can say regular expression underscore and at substitute quote space quote to replace those with spaces. And then I'll be able to actually route it like normal using a route object. So now if I'm clicking on this, now I get this, and I need, basically I just need that third value. I need the second value and the fourth value. So I could say unpack symbol integer 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 and just take this one and a toggle on this right here. This will be which ball I'm grabbing and whether I'm holding on to it, whether the mouse is down or up. That's ball 59, that's ball 11, right? So you could do something with 64 balls and it only triggers something when the particular one is triggered. Cool? So let's look at, now we can save this as multiples. GL Fizz multiple. I'm going to call it. All right, and then let's look at how I implemented this in a big old patch from the website. So go to the website and go to week 12. This video on week 12 is from last year. I didn't delete it because it's kind of cool and it looks at some more OpenGL interactivity. So if you want to look at that, that's from last year, that's fine. And here are the patches from that. It might be cool. But we want to download Cheerios and all these wave files and all the pictures. So Serial Chomp, Cheerios.maxpat, Cheerios bowl, JPEG, Cheerio text 4 PNG, and the yum.mp3. Okay, then you can open the patch, and hopefully the Cheerios, that your pictures just show up here. These 2 pictures. If they don't, you can just grab them from where you downloaded them and drag them over that to replace the picture. Same thing with the wave files. I think that's something we have to do at least. Mine didn't show up, so I have to go downloads and put these wave files in. So yum goes here. There we go. And chomp goes here. There we go. And so what I did here is, and so do I have to turn on the Q Metro? No, I set it to go automatically. So this is just a cereal bowl. Where the heck is my window? There it is. And it tells you how many different Cheerios are there. And as you click on them, it makes a chomping sound. And oh, I forgot to turn on the I forgot to turn on the sound. There we go. And subtracts how many are left. And when you get through all of them, and all I'm doing here is to get these to go away is changing their scale to 0. They're actually still there, you just don't see them. But I'm counting how many have a scale that's bigger than 0. And then when that gets down to 0, then resetting the scales all back to their default value and triggering a different sound file. Come on, I have too many. I still have 40 more. This is going to be the first one to finish. So when it triggers it all, it should say yum. A Furby should say yum. I tried to find a little kid saying yum, but I couldn't find one. I'd have to record it myself. I don't have a very good little kid's voice. Come on, darn it. Sometimes it doesn't work. So actually, you could use this method to be like a shooter, a first-person shooter, right? I don't have to set these to 0 size. I could use the fact that I triggered them to trigger some sort of animation, and then disable them or something. Here we go. Okay, so let's look at how this works really quick, and then I'll give you the rest of the class period for lab time. So like we saw before, I used a noise here. I just have a JIT P window here to actually visualize the noise. But this is float 32 noise, 64 different values. We send that into the fizz multiple for the scale thing, and then into the GL multiple, and then into the grid shape. And the grid shape has a particular texture called Cheerio, right? And the shape of a torus to give it the Cheerio shape. And we defined that texture up here using GL texture named Cheerio and sending a picture into it. So that way we can load that texture onto the Cheerio. We put this in the background on a GL vid plane with transform reset 2 so that it fills the entire screen. Depth enables 0 so that it doesn't look at Z depth sorting, and instead you can specify a layer, and I put it on layer 1 and everything else is on a higher layer so that this is always in the background. We set the world box to bigger than default. Default world box is only 10, so I set it to 30 to give more room for the Cheerios to float around. Set the gravity to 0. This is what the default gravity is negative 9.8 in the Y. That has to do with what, meters per second acceleration, curve of gravity on 1g acceleration on Earth. Yeah, and so then we already looked at how we spawn things over here, but what we didn't look at is forces. And so I'm just creating a same sort of noise here that I did over here. 64 different noise things. I kept it in the 4x4x4, but still it ends up with 64 values, and that's all the thing cares about. The range, so then I'm multiplying that by 20 so I can get forces that are way beyond 1. And then same thing, I'm dividing that by 2 and offsetting the values so I get negative forces and positive forces. Packing those back up into a list. Oh, I didn't really need to unpack these. I could have just did it with one JIT.minus. I think the reason why I was unpacked and packed before was because I was trying, originally my idea was to have something coming out of a volcano, and I wanted the Z and the X forces to be all over the place, but the Y forces to always be up, so that it's always throwing the lava up, not throwing the lava down. So if you unpack it, then I can do a different math operation on the Y, right? Question, yeah. This is how you'd make a physics-based particle system. The old particle system, so yeah, this is just you're instantiating objects' positions based on the input matrix here. Then the other forces or other parameters that you defined in your phys multiple, that's what instantiates those and where they're going. Also influencing that would be gravity. If I turn gravity on these, a lot of these are going to fall down because they don't have enough force to keep them in the air. If they do, they might still be in the air, but I just set gravity to 0 so that everything falls over the place. And then I'm constantly changing this. Every 1.5 seconds, it gets a new force vector applied to everything. So everything's kind of chaotically falling in different ways, right? Yeah. So that's that. I'll just show you really quick the other particle system, but it's kind of hard to work with and it's a pain. And it's called jit.p.shiva. And I will just show you the help file on this. So open up the help file for jit.p.shiva and look at these two windows over here. And click on 3D presets. What do I have to do? Oh, there is a Q Metro here that you have to turn on. There you go. And if you turn on the Q Metro and then click on one of these 3D presets, you can see how it's generating particles here. But it doesn't actually draw these particles. There's a subpatch in here that somebody's created to actually draw this stuff. In here. See, they're doing a jit.lcd and they're using these messages to draw everything. So all this does is create a matrix. You could actually attach your jit p shiva to a jit phys thing to actually spawn them, but the jit p shiva and Vishnu forces, jit p Vishnu forces, those are going to change the position of the particle, and that position might be counteracting what the physics universe is trying to do. So it's like it doesn't make a lot of sense to have something that's controlled by this system and is on rails in another system, right? There's no reason to have physics if you're not going to use the physics. So you either use jit p shiva, but it's really old and hard to use, or you use the physics, which in my opinion is easier to use and is more powerful and newer. So, yeah. That's why I didn't really show you guys this over the semester, but it does exist. Cool? That's all I wanted to show you. So we'll use the rest of the class for lab time. I'm going to come around, see what you guys are doing, answer any questions you have, or make any suggestions if you're stuck. All right, cool.